Welcome to Math 1314 question and answer sessions. Today we will talk about complex number, chapter 1.3. To start, we will review on this chapter. So, on the left-hand side is the diagram about a complex number. A complex number will include all of the number with this form, a plus bi, and a and b is the real number. Okay? So for the real numbers, it belongs to complex number. Non-real number complex number also include in complete number set. So you see the real number is in orange square, and that orange square include like the more orange, can say yellow right here, the rational numbers and the irrational numbers. Then like the smaller set will be inside of the bigger set. So for example, if we have number 1 right here, that inside of the natural numbers, it belongs to it. So it's also a whole numbers because the natural number is inside the whole number set. And then number 1 also an integer, is also a rational numbers, is also a real numbers, and of course it's complex number. Okay, so the same similar way we have the poor imaginary numbers. So it's right here, and it's inside of the non-real complex numbers. So if any poor imaginary number will be a non-real complex number, and also it is complex number itself. Okay, so the complex number is the whole thing include that two set real numbers and non-real numbers. The non-real numbers, just for easy, we can say that is like imaginary number. So A is the real numbers part, and then BI is the imaginary number part. So in the textbook, they say a real numbers, so A plus BI, that's the complex number form, right? But then when B equals 0, okay, when B equals 0, then that complex number become real numbers. So B equals 0, A plus BI, and then B equals 0, we have A plus 0 times I, that is A plus 0, and A plus 0 is A. So actually right here, just for short and easy, we just say it's A, just a number, without the imaginary part. Okay, for non-real complex numbers, we will have like B different from 0, right? So you can see the example right here. They have the real part, yes. They may not have the real part. If they not have the real part, what does that mean? It means A equals 0. So it's like 0 plus 3i. That equals 3i, right? So that real part right here equals 0. So we can say we don't need that A because A equals 0 in that case. So to be the poor imaginary number, it will have a form look like as BI. Okay. For non-real complex number, it just have like the form of A plus BI, and B have to be different from 0. If B equals 0, then what? Then we have the real number. Okay? Okay, so we have I is equal to square root of -1. So if we square both sides, the square root and the square is cancel out, right? So it's left with -1. That's why we have I squared equal -1. For additions and subtractions, we do the real part with the real part. So real part right here, real part right here, we add them together and it make a new real part. Okay, for the imaginary part, we have here the first one, here the second one, we add them together. So bi plus di is b plus di. The same for subtractions. For the multiplications, we still distribute, right? So a times c, here the first term. Then we have a times di. We have a times di. Okay, we have bi times c, so b times ci. Now, how about this term? Remember, we have bi multiplied by di. That is b times d multiplied by b times d multiplied by I squared. And I squared is equal to -1, so that becomes minus bd in this case. So property of complete conjugate. The conjugate is, you see that the part right here is the same. The real part is the same. The imaginary part is the same, but it's opposite inside. So plus and minus is opposite. And the result only is always will be the real number. Okay, real number. So to find the quotients of two complex numbers in standard form, we multiply both numerator and denominator by complete conjugate of the denominator. So we say if we have the denominator is this part, so the conjugate will be this part, and opposites. Okay, we're good to go for some practice questions. Okay, so let's say if I have a number, let's say if I have -5, so what -5 will belong to is negative, so it's not the natural numbers, it's not the whole numbers, but it's integers. So yes, -5 is integers, and also -5 inside of rational numbers, so -5 is integers, rational, and also real numbers, and also complex number. Okay, because inside. Got it? Okay, so let's say if we have something like minus square root of 3. Isn't square root of 3 is not some number you can write down right away? It's like a long numbers, long answer, so it will be irrational. Irrational. And also it's inside of the real number. And also it is complete number. How about if we have 3 plus 4i? 3 plus 4i's. So b different from 0 is 4. A is the real numbers. We have both real part and imaginary part. So this one is the non-real complete numbers, also is the complex number. because you can see both real and imaginary part. Okay, let's do negative AI. Okay, so you can see that negative AI only have the imaginary part. The real part is 0 minus AI, right? That's AI. When you don't see any part, just like in real number is lacking of the imaginary part, so it's only A. For the poor imaginary numbers, you don't see real part only. That's why they say poor only. So poor mean only imaginary number, imaginary part right here, the BI. Okay, so negative AI is a poor imaginary number. Okay. Okay, and also inside of the non-complete, and then it's also inside of the complete number. We good? Now we practice on addition and subtractions. Let's do 2 plus I plus 3 minus 4i. Okay, now we have the number together, so 2 plus 3, that's 5. Now we have I minus 4i is minus 3i. Alright, for subtractions, let's do 5 minus 3i, subtract 2 plus I. I should do the opposite to see how it works. Okay, so we have 5 minus 2, okay, is 3, negative 3i minus I. Okay, negative 3i minus I, so that's negative 4i. So we get back. That's good, right? Let's do the three terms. So let's do 2 plus I plus 3 minus 4i minus 1 plus 6i. Let's do that. So we do from left to right, just all number together. So 2 plus 3, right here, plus 3 is 5. Then we minus 1. Okay, 2 plus 3 minus 1. That's our real part. Now the imaginary part, we have I minus 4i. So let's say plus I is 1 minus 4 plus minus 6, right? Because the minus right here, so minus 6. So this is the imaginary part. So we simplify this one. 2 plus 3 is 5 minus 1 is 4. Okay, so 1 minus 4 is negative 3. Negative 3 minus 6 is minus 9i. When we do like with like the parentheses, it's kind of like confusing. But if you take off the parentheses, it should be just like you do x plus 1 times or minus 2x minus 4. If we do the same as that, we just like x plus 1, then we distribute that negative inside, that minus 2x. Distribute inside that plus 4, right? And then we just combine like term. So x minus 2x is minus x 1 plus 4 is plus 5. So we do kind of the same. Let's say we have 2 plus I right here, and then because of the plus, we open parenthesis. Without the, we have 3 minus 4i's. Since the positive in the front, when you distribute, it will be the same as x plus 1. It doesn't change any sign of the term inside the parenthesis. But if it's negative, when you distribute in, that will be changed the sign. So inside is positive 2x. Now it become, when you open the parenthesis, it become negative 2x. Inside parenthesis is negative 4 because of the negative outside. When we distribute, it will become positive 4. So similar to that, right? And then we combine like terms. So this one is the real part is 5, and then I plus I minus 4i's is negative 3i's. That one is still like look better for me, I mean. And then also we can do this one. Let's do 5 minus 3i. Then we have the negative, remember? So minus 2, because this one is plus 2. So when we distribute, making sure we distribute it all to all terms. So that negative I right here. So we have 5 minus 2 is 3, and then negative 3i minus I is negative 4i. See? Similar to this one, let's do 2 plus I plus 3 minus 4i's. Because that positive right here, it doesn't change the sign inside the parenthesis. So this one is negative. We have to change it. So positive 1 become negative 1. And then positive 6i becomes negative 6i. Now combine like term, 2 and 3 is 5 minus 1 is 4. So equal 4. Now I minus 4i is negative 3i minus 6i is negative 9i. So the answer should be the same, right? But we work like in the way is similar to whatever we did with the real number. Let's move on to the multiplications of complex numbers. So if we have two terms, right, a plus bi plus c plus di, we explained it already. So now we have some example. Let's do 2 plus I for easy. We multiply by 3 plus, let's say 2i. Easy enough. Okay, so we do just like distributions of x 2 plus x times 3 plus 2x, just like that, right? So we do 2 times 3 is 6, 2 times 2x is 4x, plus 4x, x times 3 is plus 3x, and we have x times 2x is 2x squared. Then we combine like term, 4x and 3x is 7x, 6 we drop down, and plus 2x squared, right? Just like that. So we do the same. 2 times 3 is 6, 2 times 2i is 4i, I times 3 is 3i, I times 2i is 2i squared, right? Now we combine like terms. So we have 6 plus 7i. But one more thing for the imaginary numbers, for the I square, we know that value is negative 1. So we have to plug it in. So plus 2 times negative 1. That becomes 6 plus 7i, and then we minus 2 because 2 times 1, negative 1 is negative 2. Now combine like term again. 6 minus 2 is 4 plus 7i. Okay, without looking at the formulas, we can also do it, right? So you see what is the minus BD, right? In this case is minus 2. So here is A, B equal 1, yeah, 1i. Here is an D, here is C. So we have here is 6 is become A times C. A times C is 2 times 3. Yeah, minus B times D is 1 times 2. So 6 minus 2 is 4. Okay. Then plus A times D, A is 2. 2 times 2 is 4. B is 1. 1 times C is 3. So 4 plus 3 is 7. Plus 7, and don't forget the I right here. So we have 4 plus 7i. Similar. But then you have to memorize the formula. Just like do like normal like this. You don't have to just like distribute like the normal real case. We just have it. Alright. Now we go to the quotients of two complex number. Let's see, I have 2 minus I over 1 plus I. That easy. I want to make the quotients. And like we said, to find the quotients, we need a complete conjugate of the denominator. So the conjugate of 1 plus I is 1 and I, but opposite. So that should be minus. Okay. If we have the case that 2 minus I over 1 minus I, the conjugate will become 1 minus I is the denominator. The conjugate will be 1 plus I. 1 is keep the same, I is keep the same. The only thing difference is the sign. Okay? So let's erase this. And then now let's practice on this one. So we multiply the numerator and the denominator both by the complex conjugate. This is our conjugate. Okay, so we multiply 1 minus I over 1 minus I. Okay, let's do the parenthesis. So for multiplications, the fractions, we do numerator to numerator. So we multiply 2 minus I multiply 1 minus I. That the numerators. The denominator will become 1 plus I times 1 minus I. And the thing is, we can always remember this part. So we have 1 plus I, 1 minus I. So in this case, A equal 1. And then B also equal 1. Right? 1I right here. So the result will be A is equal 1, so 1 squared plus B equal 1, 1 squared, that equals 2. So denominators is equal 2. And also, if you don't remember the formula, you always can use the multiplications of the complex numbers to solve for it. So 1 times 1 is 1. 1 times minus I is minus I. I times 1 is plus I. I times negative I is negative I squared. Now 1 minus I plus I is gone. Minus, okay, minus I squared is negative 1. Remember, I squared is negative 1. So I squared negative 1, you put negative 1 right here. Now the negative in front of the parenthesis, when you distribute, it becomes positive. So positive 1, then it's equal to. See that? We can still do it using like the multiplications method, but then if it will be faster when you memorize this one. Alright, so the bottom will be 2. Now for the numerator, We have 2 times 1 is 2. 2 times negative I is 2. Negative 2i. Negative I times 1 is minus I. Negative I times negative I is positive I squared. Okay. Now we continue. We have I squared is negative 1. So 2 minus 2i minus I is minus 3i. I squared is minus 1. Now simplify it. 2 minus 1. Combine like term. 2 minus 1 is 1. Minus 3i over 2. So this is the answer. Let's write down again so it's not confusing. This is the questions. 1 plus I. Okay. This one is conjugate. Thank you for participating in this review. I hope this video will help you to complete your assignment and have a great day.